In this video, we're going to see an example of transformation from one random variable to another. In our example, we're going to consider a standard normal random variable x. Its mean is 0, variance is 1. And we have a function y equals x squared. So y is the new random variable, and we're interested in finding its PDF. We're going to use this approach. If we have an invertible function y equals g of x, then the PDF of y is given by this sum, where px is the PDF of x, and we have this derivative of g of x with respect to x, and we have its magnitude. We need x equals xi. Xi's are the roots of this transforming equation y equals g of x. And there could be multiple roots, and we call them x1, x2, x3, and so on. So for our example, we're going to start by differentiating g of x with respect to x to get this derivative. It is 2x. Then we'll find the roots of x squared equals y. There are two roots, x1, square root of y, and x2 is negative square root of y. And once we have these, we're going to apply the formula we have. Py equals this sum. And in the sum, we need px. Px is the PDF of x. Since it's a standard normal random variable, the PDF is simply given by this. Okay, so using this formula, py is now given by this sum. And since we have two roots, we're going to have just two terms in that sum. So expanding out that sum, we get this expression. And now after this step, all we have to do is substitute the expression for p of x, x1, x2, and the derivative. So for the first term, what we did was we took the expression for px, and we replaced x by x1, that is square root of y. And we also took the derivative of g of x, and we replaced x by x1, that is square root of y. So that gave us this first term. And for the second term, instead of x1, we used x equals x2, that is the negative square root of y. And it gives us this expression. Now we can see that we can take the square of the square root and we get a y. Here also we get a y. The minus sign can be removed because we have the square. And we can get rid of the magnitude because y is always going to be a positive number. Square root of y is also going to be non-negative. So we can get rid of the magnitude here. Similarly, we can get rid of the magnitude and the negative sign as well. So once we do that, we get this expression. And then note that these two expressions, the first and the second terms, are now identical. So we can combine them. And combining them, we can get rid of the half in the denominator. Also, this square root of y can be moved over here. We can write it as square root of 2 pi y. So doing all that, we get the final expression, which is going to be this. And this is the PDF of a random variable that has chi-squared distribution with 1 degree of freedom. This is a central chi-square distribution.